So let's do a couple of this weird equation, no? Okay, look at the step. And the step is number one. Third, professor will be final exam be mandatory. No. No, only the student. I when I send, good question. When I will send the test number 5, I will send together the final, and you make a decision to take or no. That depends if you want to improve your grade, and your grade is easy to compute because you average every test we are doing. Actually, we have 10, 5 chapter, 2 tests per chapter. You adding divided by 10, no? Entonces now you get approximately what is your overall grade, no? So you want to improve, you take. I highly recommend. And also you have 8. No, it's totally unnecessary to take the final, no? But also you want to improve, you take. And I will grade. The only disadvantage of the final is case community, everything together at the beginning. But it's okay. Now, suppose que you're doing the mess because you don't remember anything. Entonces no problema. Doesn't affect your score, right? Only improves when the SBS is good. I include in the equation a little bit improving grade. Good. Good morning, Professor Michael Lopez. Okay, do you follow me? Do you understand very well the explanation or not clear? Come on. Clear the topic of the final. Thank you. Okay, let's do it in the first problem. The first problem say x over x plus 4 change too much plus ax plus 28 over x squared plus 7x plus 12 equal x minus 3 over x minus 6. Entonces, I try to explain here. Look, this is a step. Factor denominator of all rational expressions. Identify LCD. I include here an identification restrictions. And multiply both sides of the equation by the LCD. This is allow us to clear the fraction, eliminate the fraction. Solve it and check the solution. Okay. This is another way. My way is you determine the restriction and you know what the solution is wrong. And however, they omit the step of the checking the restriction. No, they don't talking about restriction. And you solve the equation and you plug it in. Of course, you don't plug it in the value que es the restriction. So the first step, they are perfect coincidence, que es factorization. And factorization, well, the only guy I guess possible to do something is this. It's xx, and the combination that open the door of this trinomial is 3. 3 is 12, 4 plus 3 is 7. Therefore, our LCD is x plus 4, take one time, x plus 3, and x minus 6. Done. Now the restriction associated with this LCD is x no negative 4, x no negative 3, and x no positive 6. Any solution equal this, you eliminate. Everyone follow me so far? Oh no. It's confusing?
No.
No. Okay, now I multiply the long LCD because it's long, one by one, here, here, and here. Therefore, when you multiply, we have x, this x is this, time, well, the other factor que belong to the LCD and is not in the denominator of this fraction because this and this is cancelled, at least in this part, no? X plus 3 x minus 6, something like that, plus ax 28. Who cancel? Is it cancel again? And it's cancel again. Again, no. That is the first. Multiplied by x minus 6 equal, and the last we have x minus 3, get the numerator part. This is cancel and stay alive this and this. And the right hand side, x plus 4, x plus 3. So far, everyone follow me? Do you understand very well the thing I'm doing?
Yes.
Well. Look like complicated, but no. It's long, I know, but not complicated. Okay, look, I take advantage everything. I apply FOIL in between this, and after multiply by x. Entonces es x. So far, I keep it. And you FOIL x squared minus 6x plus 3x minus 18. Why not in the next line to don't confuse me? Violator is minus 3 minus 18. Okay. Whatever you multiply is x cubed minus 3x squared minus 18x. Either way, plus another FOIL here. Multiply ax minus 48x because 8 times 6 negative plus 28x minus 28 times 6, you put it better, is 168. So we combine like that, why not? In this case, I go directly here, s plus, let me see, this is a square, no? I make mistake here, right? This is a square, because this times this is x squared. This a is x squared minus 20 gets subtraction 48 minus. You know, I put the sign of the big minus 168. Okay, at least I did that part. If you want, you move to the right hand side, or no, you highlight term here, why not? Is x cubed. Square is this and this, fi, 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 plus phi, and this is 38 minus 38 x minus 168. Okay, not bad. I focus it either way, guys. You can do simultaneous left and right, either way. Let's doing the part, and so I propose you, well, I take advantage of this. Look, this guy and this guy together is conjugate. And conjugate is super easy. The multiplication is x squared minus 9. Okay, remember the famous formula, que is a plus b and a minus b is equal a squared minus b squared. Identify, wow, fantastic, I like that. X minus 3 and x plus 3 are conjugate. This is special multiplication. You multiply first and last, and you always minus in between. Like 8 times 8, a squared. B times b, b squared, and minus in between. Basically, so far we have x squared minus 9 and x plus 4. And now I am ready to apply FOIL. Multiplication, x cubed plus 4x squared minus 9x minus 36. So far, this is the equation that we have. I know that's too long. If this is the problem in mathematics, if you make a mistake in one stupid signs. Of course, you screw up everything. So try to relax. Don't rush. Slow down, little by little. Okay, entonces I see que da part cancel. Excuse, I like that because I don't like cubic. Because I realize that this equation is quadratic equation. So I copy. 5x squared minus 38x minus 168 minus 4x squared. I bring everything to the left because I want to put the right hand side like a zero, no? Equal to zero. And one more time, we combine like that. 5 minus 4 is 1. Like that. This and this. 38 and 9 is 29. No? 29. Let me see. Got the calculator here. 29. No? Yeah, absolutely. 38 minus 9, 29. But of course, negative. Negative 29 x and 168 minus 36 is minus 132 equal to 0. This is the final quadratic equation that we have in this moment. No? It is a little bit complicated to find the key, open the door. That's the reason in the chapter 5, the last chapter, we study another powerful way to solve this equation. Using the quadratic formula, but no now. Now, so far, the only possibility we can do that is by factorization. It's the only thing that we are studying. And the combination of open the door is not obvious, but is 33 and 4. Because 33 times 4 is 132. And 33 minus 4 is 29. The signs are negative here and positive. So we have two solutions. The first solution is 3, and the second solution is negative 4. But it's an important moment in which you compare the solution of this new equation that we transformed with the restrictions. I see that negative 4 is no good because it's coincident with this. It's totally invalid. Now, the only solution that we have in this equation is this. 33. The question, you follow me or no?
Yes.
You are strong, no? Doing this, no? Consider it's important to do this or no? Number 6. Or you are boring to do this? What do you think? We move on to the next page. Let's do it or no? Or you understand very well or it's totally irrelevant? Answer me. You consider important to do number 6 or no? Yes or no?
Yes. Yes, please.
Yes, please. Okay, no problem. Try. Okay. This is long. Very, very long. Too much. Is x plus 2 over x squared minus 16 plus x minus 3 x squared minus 3x minus 4 equal 2x minus 3 x squared plus 5x plus 4. Remember, step 1, factorization any expression in the denominator. Factorization this, factorization this, factorization this. I don't care. Numerator not important. So this is the classical difference of a square. This is trinomial and trinomial. And the factorization is x and square root 16 and 4, so minus. We are doing in 1 second. And this is xx, is the variable, and this is 4 and 1, I guess so. Times 1 and 4, 4 minus 1 and 3, minus 4, different sign. And here xx, and again 4 and 1, because 4 times 1 and 4, and 4 plus 1 and 5, the sign is plus. I am doing step 1, factorization, the denominator of all radical expression. Okay, entonces en one corner of the piece of paper, I dedicate my time now doing LCD. LCD always is the collection of the any factors, but you need to collect every factor, no omission. The factor involved in my problem is R, x plus 4, x minus 4, x plus 1. That's it. Take this. How many depending on the problem, but you take majority. You have, for example, x plus 4. I saw here and here. It's repeated, but you take only one time. Okay? As you have in one expression, x plus 4 square, and you take 2. Okay, no, it's only one. X minus 4, you see here, you take one time. X minus 4, and I saw also x plus 1, see here and here. This is my LCD, easy, no big deal. And the other was long, this is short, 1 to 3 only. And the restriction associated with this is important step because allow me verification see you have a extraneous solution or not. No 4, no negative 4, no positive 4, and no negative 1. Okay, now ready to multiplication. When you multiply, our LCD is this. Time the first fraction, we get x plus 2, x minus 4, x plus 4, and x minus 4 cancel, and stay alive only x plus 1. Okay, not bad. Plus x minus 3 gets the numerator of the second fraction. We are doing that part now. Well, multiplied by I don't know, x minus 4 is cancelled, and x plus 1 is cancelled. Stay alive, x plus 4. And the right hand side, we have 2x minus 3 by something, x plus 4 is cancelled, x plus 1 is cancelled, stay alive only x minus 4. You need to be aware in that moment that this equation is easier than the original, is no equivalent 100% to the original. Okay, therefore, maybe you finish, we have straight solution or no. The rest is baby algebra. You apply FOIL. Here is x squared plus x plus 2x. Guys, if you want, either way, you FOIL here now. Oh, we continue processing the first expression. I don't know what do you consider is better. Either way, in this case, I like this. But sometimes I don't do, I did different. Okay, it's not important. Now FOIL again, and the other is plus, to process this plus, I bring down x squared plus 4x minus 3x minus 12. X plus x squared plus x, because 4 minus 3 is 1, equal. And moving on to the right hand side. Right hand side is FOIL again, 2x squared minus ax minus 3x plus 12. is 2x squared minus 11x. Okay, and the left hand side, I forgot to combine lighter. Detecting this and this is lighter, x squared, and this is lighter also, 3 plus 1, 4, and this is lighter and minus 10. Equal to x squared minus 11x plus 12. Wow, I like that. This part is cancelled out. Actually, this equation is no quadratic equation, it's linear equation. And linear equation, I know very well, can have one solution. Okay, entonces this solution, see we have solution, the one solution. I suppose, no, I'm not sure 100%. Is no coincident with the restriction, no? Si es coincidence, we have no solution. As the 4x stay here, I move 11 to the left, change the sign, negative to positive, and this is 12 stay plotted. Ready, 15x equal 22. 15 both sides, x is equal 22. Entonces, in this case, impossible to do anything because they are not common factor. And we cannot reduce on lowest term, but I immediately compare this and this, no coincidence with the restriction. This answer is correct. The answer then is x is equal a fraction e2 or boom, final answer. Any question? How do you feel in this solution of this equation? In the test, I don't put too complicated. But I put okay, super. So let's continue the next page. Next page, I want to show you another topic, no? Let me see next page. Next page is the page number 3, no? I get page number 3. So, okay, this is one topic I don't cover in my lectures. Of course, I don't put in my test, but just in case, and Alex, maybe yes, you have that. Okay, find the constant. Okay. There are two. It's a variation. It's this topic, but it's super easy. Variation. We have look. We have different kind of variation. It's directly proportionally and inversely proportionally. What mean that? Suppose that one quantity, you have two quantities, y and x, or whatever, a and b, and they are directly proportionally, look here, very directly as x. If the formula is y equal kx, and k is the constant. So they are a connection, linear connection, is a constant. This is classical in the real life. Suppose we have the shoes and the price of the one shoe, the unit price is $50, no? The K is 50. I want to find how many shoes, for example, what is the price of the 100, and you multiply 50 times 100. This is directly proportional. $5,000. Now, no 100, 200. Entonces multiply by 2 is 10,000. This is the most common law of variation that you know. When it's directly proportional. Keep in mind this name, directly proportional. It's important that directly proportional is when the x, is the independent variable, increasing, the y get dependent variable increasing also. and increasing in the way that the division y over x is always constant. And this constant is called constant of variation. Okay? Okay. This is just definition, just the name, no big deal. Everyone understand that. But in the problem number one say the variable y vary directly as x and y is 20 and x is 80. Okay, okay. The problem says that y is 20, x is 80. Yeah, I need to find k. K is the variable directly because they want to find the constant. Well, you divide 20 over 80. The zeros cancel, it's 2 over 8, and you reduce and lower 1 over 4. This is the constant, this is k. Any question? This is the formula, guy. Now, okay, clear. No. Eric. Suppose now number 2 is similar, no? Is x is equal 3 and y 15, no? So you divide. You divide y divided by x is 15 divided by 3 is 5. 5 is the constant of. Okay, not bad. It's easy. Variation. But we have another kind of variation, okay? It's inversely proportional. What is the formula? Oh no, this is the formula. Look, this is the formula for directly, and this is the formula of the inversely proportional. The formula is, let me show you. It's not multiplication, it's division. This is division. What happened? Y equal k x. K is a constant of proportionally. Okay, so it's inversely proportionally when the x increasing, y decreasing. This is the idea behind inversely proportional. So when the denominator is going up, it's growth. The quotient is obvious que it's going down, no? See, it's suppose you have, I don't know, something. $400. And you need to split this in 2 people. Oh, well, it's 200, no? That means you split that $400 in 2 people, one guy, and 200 another guy. I suppose that you increasing a little bit the denominator, que es x. Because no, 2 people is 4 people. So 100. Oh, it's logical because 400 split in 4 people is 100 each person. And so on. So that proof clear that when the our denominator increasing, the result of the formula is going down, decreasing. It's extremely logical. Entonces now I need to find the constant of proportion. That's the formula. And constant of proportion is k, remember, right? And the number 3 and number 4, we need to find the constant of variation and write the equation of variation. Okay. I forgot here. I forgot the formula. No, and write the equation of variation. The equation in the 1 and 2, I forgot. Y equal, the constant is 1 over 4. You put 1 over 4 x, no? And the equation of variation in the second, it was 5, no? 5x. And here I have no idea. Let me try. To find the constant of proportion, a different operation because you apply cross multiplication here, right? So it's k is y times x. So it's y is 0.5. Look at that. And x is 3.8. Multiplication 3.8. Put in the calculator, of course. Is 0.5 times 3.8, 1.9. 1.9 is a constant of variation. And what is the equation que state relationship between is y equal 1.9x. This is the equation of variation. Okay, it's similar. And number 4 is, the constant is the multiplication. This is the variable now. Because the variable change according to the problem. No, this is a t and this is z. Okay, the formula would be, I suppose que c is the dependent variable, the constant of variation, and divided by t. This is the formula. And k is the multiplication c and t. In our specific example, is 2.3 multiplication by 72. 2.3 multiplication 72 is 165.6. It's a constant, and the formula is C equal 165.6 divided by T. Boom. Done. Any question? This is easy. It's not extremely important. At least in my test, I never put that. So maybe you need to be aware, because in Alex, maybe you have some question about that. Okay, do you understand or no? Confusion? All right, I understand. Okay, let's move on to page number 4. Page number 4. Page number 4. Page number 4. Page number. Page number 4. Oh, page number 4 is application of this variation. Is a word problem, no? Okay. I know that you don't like word problem, but you need, because the application of the mathematics, right? Entonces you read carefully the word problem to understand what they want, and you set out the equation. No? The number of patients of the Doctor Wong can see very directly as the time it take her to see them. We have two variables. Patient, let me call P, is patient. And another variable involved in my problem is the time. And very important, this word, directly, very directly. So we have a constant K and time. Wow, fantastic. This is my equation. State the relationship between the number of patients and the time taking her to see them. If she can see 11 patients, basically, this is a typical example. We have two conditions. Condition 1 is given, and condition 2 is given pero partial given, and you need to find one piece of the condition 2. Okay, there are many ways to do this. One way, classical, is you plug it in this formula. P is 11 patient. Okay, I have no idea, and the time is 3 hours. And you find the constant K, 11 over 3. It's okay. And use substitution in this formula. K que according to the condition 1 is 11/3. Therefore, P is equal 11/3 multiplication by time. Entonces, en the second condition, how long they want to know the time spend Dr. Wong something to take her 66 patients. So basically, and the condition 2 is giving the number of patients is 66 is equal 11/3T. So for T, and the story. So for T is super easy. Remember the shortcut to do that. When you have fraction, you multiply by reciprocal. It's 3/11 both sides. Okay, entonces magically happen que any number time is reciprocal at 1. Entonces es just T. And 66/11 is 6, and 6 times 3 is 18. T is 18, I suppose que es hour. Now let me see the unit we using. Yes, 3 hours, 18 hours. Spend the Dr. Wong to see 66 no patients. Make sense? Complicated or easy? A ver, easy. You only need to remember the formula. And the formula is important. Is giving in this word directly. Si es inversely, entonces es another thing. Okay, let me do number 6 problem. The 6 problem say the speed of vehicle vary inversely. Oh, speed. I suppose that the first variable is speed. Speed is, let me call, what? Can call speed. I know. Pues, very inversely, si es inversely, I know that the formula of the inverse is a constant, que normally we call K, and another variable inverse to the time. This is my formula. This is my formula. Okay. Remember, condition 1, condition 2. And the condition 1, if the vehicle travel a fixed distance at 20 miles per hour, at 20, speed for the condition 1 is 20 miles per hour. And the time, let me call time, why not? Time, not T time. Either way, you define your own name and the variable in the word problem. It's 60 minutes. Bueno, entonces there, you know, the thing I try to illustrate this word problem is to compute everything, we need to matching the unit. Matching the unit because see the speed is given in miles per hours and the time is not given in hours, so we have a big problem. Entonces, pero I know que 60 minutes is 1 hour. It's equivalent. Okay. How fast? How fast? What means how fast? I need to find the speed and the condition 2. Question mark. Bang. How fast it travel to cover the same distance but at different time. Time now is 25. To express it in hours, why don't you divide it by 60? 25 divided by 60. Oh, it's a weird decimal. I don't know. Let me try in fraction. 25 60. Okay, 5 over 12. So you divide 25 over 60, it's obvious. It's in fraction 5 over 12 because you divide by 5, no? Divided by 5, the top 25 divided by 5, 5, and 60 divided by 5. This is hours. Okay. Now, what should I do? Well, I know the formula is inversely proportional. Okay. I need to find the constant. For using the condition 1, everything is given. The constant is K, is multiplication, the speed, multiplication by the time. How do you know? Because it's cross multiplication. You multiply 20, 20, 20, 20, 20, 20, multiplication by 1, no? Is the time in hours, no? The same unit. So K is 20. 20, I don't care the unit. The unit is not important. It's 20. Now, I go to the condition 2, in which you don't know. Remember the formula. I modify the formula now. The formula is my specific formula for the problem is look. The formula is, I don't see very well here. Speed is equal 20 is the constant I found here divided by time. Okay, and they want to know how fast is speed. It traveled to cover the same distance in 25 minutes. Okay, 25 minutes. Oh, okay. 25 minutes. Okay, 25 minutes. So now I know that the time is 25. So 20 divided by 25 divided by 5. Reduce the lowest term. Divided by 5, 4. Divided by 5, 5. You put, if you want, you put in fraction, and in decimal, sorry, is 0.8. 0.8 watt. 0.8 mile per hour. Because I suppose que si es the same distance, pero you go to the 25, so you go slow. 60, you go fast. Is 20, 0.5. All right, 20, yeah. That's the answer. Yeah, do you understand or no? Yes or no? Cool. Okay, this is the page 4. Now let's move on to the page 5 and the review. I like that part. Part is easy. There's the manipulation, fraction exponent, and using the rule of exponent. Example, number 1 say 27 raised to the 1/3 exponent. I need to know if the fraction exponent is a radical. You convert immediately to understand more clear like a radical, and this number gets 3, and the denominator of the fraction is the index of the radical. Oh, I know that it's 3 because 3 times 3 times 3 is equal to 27, is exactly the number that we have inside the radical symbol. And the total. I know by memory. I know by memory that the some cubic, not all. For example, cubic root of 8, cubic root 27, 3. cubic root 64 F4 and cubic root 125 F5. At least I know by memory this. The rest no. So you put in a calculator. But it's useful, I suppose. Memorize some. Okay. Lesson number 1 was easy. So now number 2 and number 3 are very, very similar, but it's tricky. It's tricky. So now, suppose we have minus 16 raised to the 1 over 4. Okay, you need to be careful. I want to copy simultaneously 2 and 3 look like similar. But no, it's not similar. Okay, this negative without parentheses is like a negative one. So in your mind, in your imagination, you see this situation, believe that this is negative 1 times 16 raised to the 1 over. Now you totally ignore. No, ignore totally. You keep it, but do not participate in the operation. No? The operation is minus, because this is negative 1, factor negative 1, and now 4 root 16. You compute yourself independent, 4 root 16 is 2, and the answer is negative 2. See? Right. This negative you consider like a 1 factor negative 1. See, it's inside the parentheses. No, be careful, because this is inside the radical. Okay? Do you see the difference? And of course, we have no real solution. And when you have, be careful, when you have negative numbers inside the radical that contain index even number, no, this is not real. I explain in detail in the chapter 5 this idea. So you memorize this. However, when the index of the root is odd, yes, we have real solution. Okay? Let me see example 4. Example 4 is negative 64 raised to the 2/3. You try to understand using radical notation, que es better, huh? You put a cubic root of the negative 64, because it's inside the parenthesis, similar to this, and you raise to the second power. Associate, guys. This 3 is this 3. This 2 is this 2. This minus inside the parenthesis is inside the radical. In this case, yes, we have solution, because the index is odd number. And what is the solution? The solution is negative 4. Because negative 4 times negative 4 times negative 4 3 times. So negative 4 times negative 4 is 16 positive. And 16 positive times negative 4 is exactly negative 64, because the number inside the radical symbol. Does this have solution when it's odd? When it's even, never real solution. And the answer is negative 4. Negative 4, but don't forget a square. This is square. Entonces negative 4 squared is positive 16. That is my final answer. Do you see that? Oh. So it's important that you solving the problem definitely of the negative sign. When the negative is without parentheses or when it's with parentheses. If without parentheses, you consider it like a negative factor. You ignore temporary. You compute the part without this negative. And finally, boom, you attach negative 1. Multiplication by negative. Entonces, when it's inside the parentheses, be careful. because we have two possibilities, no solution or solution. That depending of the index number of the radical. Si the radical is even, no solution, no real solution. It's imaginary or complex, you see in the chapter 5. No, no. And when it's odd, yes. Or we have solution is, and now finally if you square become positive. No? Nice. Okay, entonces everyone follow me, no? Because it's easy. Yes or no? Yes or no? Good. Let's move on to manipulation exponent. Remember, three different rules of exponent. When you multiply, suppose this, x to the second times x to the third, x to the fifth. Where come from this 5? 2 plus 3. Okay? When you divide x to the 4 divided by x to the second, is x to the second. Where come from these 2? 4 minus 2. Okay? So when you divide, you subtract this exponent. When you multiply, you add this exponent. And you have this, the third rule, number 1, number 2, number 3, is when you have different level of the exponent, you multiply. It's x to the 6, no plus, it's time. 2 times 3 is 6, okay? And that's it, no more rule. It doesn't matter que the fraction, the exponent is a whole number, or it's a fraction, or it's positive, or it's negative. Manipulate using this rule, just universal rule. Let's do it one by one. I'm using our imagination. X to the 3, 4. We are doing number 5. Multiplication x to the 2/3. Okay, no problem. I understand. You copy, you copy separately. 3 over 4 plus 2 over 3. And you find as always LCD gets 12. 12 divided by 4 is 3, 3 times 3 is 9, plus 12 divided by 3 is 4, times 2 is 9. 8. Doing it. 12 divided by 3 is 4, 4 times 2 is 8. 17. The answer could be 17. Clear? The most complicated problem is the addition of the fraction, but we can do by hand or calculator, either way. That's a number 5. Now number 6. Number 6 is, and number 6 we have negative exponent. Time x to the 3, 4. Either way. One possibility is don't change the negative exponent. You adding. It actually is not adding, it's subtracting. Basically, it's 1 over 4 plus 3 over 4. In this case, super easy because the denominator is the same. You don't need to find least common denominator. No. And negative 1 plus 3 is 2. And reduce the lower term 1/2. The answer is x to the 1. It's a one possibility. Another possibility is case equivalent, 100%, is you change the negative exponent to positive. I copy the positive, exactly the same. And you convert the negative exponent in the denominator, like a positive. Now, actually, now subtraction, so we are doing the same operation. And we get the same result. Either way. Some people, I don't know why, prefer working with the negative exponent. Some people not. Be scared to see negative exponent. They change to positive how? Change, so suppose que negative exponent in the top. I change to the bottom like a positive. That's a reciprocal. Flip it. And negative exponent at the bottom, you flip it like a positive exponent in the. Let's practice. Let's practice. now number 7. 7 say x raised to the 1/4 times x to the negative 1/3 divided by x to the 2/3. Okay. The student want to manipulate using negative exponent, it's okay. The student don't like using negative exponent, you convert. Only working with the positive exponent. So now you put in the bottom, you just 2/3 tape times 1/3 positive. Cool, right? Now, I recommend addition the exponent because multiplication is 2/3, 1/3, is over the 3/3, get 1, and 1 is invisible. It's x to the 1/4 divided by x. Follow me? I'll leave it like that, no? I need to subtracting. 1/4 minus 1. 4, and 1 gets invisible here. Okay? Now it's obvious that it's LCD is 4, 1 minus 4, no? 4 divided by 4 is 1. It's negative 3/4. So you write like that, it's x raised to the negative 3/4. But never we express the final answer using negative exponent. This is not illegal, but it's not polite, it's not elegant. Now, how you change? Well, reciprocal, 1 over x to the 3/4. And it's a more elegant final answer. Cool? Not bad. I recall, I want to recall, yeah. Yeah, some students sent me the test number 4. A lot of students sent me the test. But the due day is Wednesday. Wednesday at midnight, as always, no? Let's do the test number 4. And don't forget to meet in Alex. And on paper, send me by. Suppose number 8 problem is 4 x to the 6th power raised to the negative 1/2. Wow. In this case, two complications because it's fraction and negative. So now we can simplification little by little. Suppose you first of all, I don't like negative, so I put it reciprocal. This is 4 parenthesis 4x to the 6th power raised to the 1/2 positive. This is one possibility in order to eliminate this negative. But I don't feel comfortable with this. No, good. I convert to the radical. This is radical, but what kind of radical? It's square root. And square root 2 is invisible. This 2 is invisible, and this 1 is also invisible. Okay, actually it's 2 here and 1 here. But in the algebra style, when the power of 1 is invisible, and when the index of the radical 2 is also invisible. Cool, I like that. And this is, I can do that. Yeah, of course you can do that. Because you can separate like a square root 4, que es 2. And square root x to the 6th power y. Suppose that we can simplification a little bit because we have 1, 2, 3, 4, 5, 6x, no? And we have one couple is x to the 3rd power. Or another possibility is you divide mentally 6 divided by 2. It's invisible 2, get the index. Not necessarily doing it that way. So the answer is 1 over 2x cubed. Final answer. Perfect. It's a very interesting and easy, no? Problem. One more. One more. Number 9. I say x to the 1 over 8 times y minus 2 thirds over x to the 1 over 4. And simplify. Of course, we have no rule, we have no exponent when you have different variables. So we can join, we can interconnection. You have x, you have no more y, this y stay the same. Of course, the final answer never expresses using negative exponent. The only thing you should do is manipulate the x part, because 1 over 8 minus 1 over 4, because of the division, no? Subtraction. LCD is obvious a and minus 2. Welcome from these two. A divided by 4x2 times 1x2. And it's a negative 1 over 8. And so far, the answer is x negative 1 over 8 and y negative 2 thirds. This answer is correct, however, no elegant. So I propose you convert to positive. But this is easy. Is flip it. 1 over x to the positive 1 times y to the positive. End the story. Everyone follow me today? Oh no, we are total loss. You understand very well the rule of the exponent? Oh no. Answer me. Are you there? Are you sleeping? Wow. Understand? Okay. Okay, cool. I like this class. Wow, a lot of the students I have here. No, online, on time. A little bit late, but I have a lot of it. Aaron, Valerie, Michael, Dai, Melanie, Josué, Apolinari, Sara Sofia, Grace. Grace, definitely you send me the test number 3 or no? Guys, it's important. It's important that you help me. You check it in Canvas, in the grade book of Canvas. See if your grade is correct, see I omit, see I forgot. You email me, no here. Email me, Professor. Grace Love. Do you send me or no? I don't remember. No, not yet. Not yet.
No, what did you say? I didn't hear you.
Oh, I say que I remember something que you don't send me the test number 3.
Yes, I did. I sent it to you via email and I also uploaded it to Canvas.
You send me with the email of Canva or the regular email?
Both.
Both.
Yes.
Please checking see I update this in the grade book.
Okay.
See I don't, so you let me know.
So send it to you again?
No, well, depende, no? See I checking. Suppose
Okay.
you say, no, I have 0. So
Okay.
entonces I checking, okay, you told me now,
Yes.
okay, you send me, entonces I checking again.
Okay.
See, I found, no problem, I great, and that's it. You know, you resend me, okay?
Okay, no problem.
Okay, let's do number 10. Number 10, you see whiteboard or no? You see the whiteboard, right?
Yes, we can see number 10.
Number 10 say minus 6 x to the negative 3 over 4 divided by x to the minus 1 over 4. Wow, too many negative. I don't like this. Minus 6, well, this is just coefficient. And thus I propose you convert everything to positive. So x to the 1, 4 at the top, the x to the 3, 4 at the bottom. Now division is subtracting the exponent. Oh, easy, because it's the same denominator, no necessary to find LCD. That's a 1 minus 3, and 1 minus 3 is negative 2. 4. and negative 2 over 4 is negative 1/2. So finally, so far, the answer is -6 x to the negative 1/2, but never we express the final answer using negative exponent. So one more time, I need to flip it. It's negative 6 over x to the 1 in the denominator. Okay. Fantastic or no? I told you, this class is easy. Next class, no. It's a little bit complicated. A little bit abstract. But it's okay. If you take with me, you have no problem. No. There are a lot of good teachers in Homestead campus. Okay, let's move on to the next page. Next page is, let me see. I did that. It's the last. And when you finish, that's it. Okay. I like that. This is super easy. I love this part. Look at that. This is, number one is square root 4x to the cubic power, no? Let me see, I don't see very well. Let me make a zoom. Oh, yes, cubic power. Okay, no problem. I understand. Okay, entonces you separate mentally. Square root 4 is 2. And square root x cubed, I have no idea. This is 2. But this is, remember, 1, 2, and 3. And use simplification by couple. This couple represents 1x outside, and this x stay inside. Makes sense, right? Another way to visualize this, x cubed, you split in x squared and x. And square root this is equivalent to say square root this and square root this. This is x because 2 divided by 2 is 1 times square root x. And we get the same result. You understand very well this or not?
Yes.
Okay.
Professor, I have a question about my grades because it says that I have a 0 for the test 3 on Alex.
Oh, email me, please, sir.
Okay. Do
What is your
I
name? What is your name to be
er,
aware?
Eric Troncoso?
Oh, yeah, I remember you're a good student. You say, wow, what the hell? No. Just wait. I need to check in, Alex.
Mhm.
You did and you submit.
Yes. Well, I think I did. But maybe I have not submitted. But I'm sure that I always do Alex first before the paper test.
Okay.
The paper test. So.
Suppose that you have situation and you forgot or you can know because you have situation, you don't
Uh.
submit. So
Um.
you 0. This is another problem. Si
Mhm.
you don't submit, be honest with me, then I can extend it a little bit. You talk to me.
Uh.
Communication. Professor, I have situation, blah, 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 blah. I
Mhm.
understand. Yeah, extending. I create extension for you.
Okay.
This is the situation.
No.
No.
I just right now I'm having trouble.
You submit regularly, like every.
Yes, I
Entonces,
do. I do it.
okay. Entonces I don't see your grade. I put 0. But I check.
Uh,
Just in
I,
case, email me to
mhm.
remind me. Okay.
I'm just trying to like right now I'm having trouble logging in because I something happened with my account, Google account, and I lost the password to the account. But I'm sure I did the test before anything happened to the Alex to
Okay.
my Alex account. So I cannot tell you that for sure. I did. I submitted because but I'm sure I did it because I always do the Alex before the paper test.
Okay.
So
Super. No
I
problem.
turn in the paper test and I don't have a grade for Alex. So
Okay. So you email me to remind me. Okay.
mhm.
Yeah, I take care of this.
Okay,
Do you
thank you.
understand that this is not the place to discuss this?
Yes,
because we
yes.
have I see in private the situation. Okay.
So,
Okay. Number two. Number two is cubic root of 54 x to the cubic power. Wow, what the hell? Oh no, I don't care. This is easy. You take 54 and you break it down 54 and prime factorization. 54 is obvious it's even number, right? So it's even number, you divide it by 2. It's 27. And 27 is divisible by 3, get 9. And 9 is divisible by 3, get 3. And this is the prime factorization of 54. Actually, 54 is equivalent 1, 2, and 3, 3. And remember, we are working with the cubic root, and the cubic root you select 3 by 3 factor. And the square root is 2 is couple. The cubic root 3, and the 4 root 4 by 4, and so on. And these 3 represent 1, 3 outside the radical. The numerical is 1, 3 outside, and 1, 2, guess this guy, stay inside. Okay? And x cubic is easy because cubic 3 divided by 3 is 1 what? Outside. The reason is x cubic is x times x times x, 3x. Exactly the amount of x that we need to go outside like a 1x. Is this. Wow. This is our final answer. Okay? Clear or confusing?
It's clear.
Hmm? I know. Number 3. Number 3 is, this is a square root now. 20 x cubic y fifth. Okay, 20 is no perfect square number. And the exponent in the problem is 3 and 5 are a number. There's no perfect cubic expression, but I don't care. You take 20, you divide by 2, get 10. Divide by 2, get 5. Oh, I see a couple of 2. And at least the numerical part. Look, I separate my problem in 3 problems. The numerical part I analyze independent, separately, the x part, and finally the y part. The numerical part is 2. The number can fly outside the radical and stay this 5 is this. Cool? Everyone follow me? Okay, now the x part.
Yes.
I split x to the second power and x to the 1 power, okay, 3. So you separate, you try to find the even number close to 3, but so say now x squared is 1x outside and stay 1x inside. And y to the 5th power is y to the 4, because I try to find even number. Why even number? Because we are working with the square root. And we have invisible 2 here, right? So even number close to 5 down is 4 times y to the 1 power. And 4 divided by 2 is y second outside and stay 1y, okay, this y is this. That is my final answer. Do you understand very well this or no? What's confusing?
No, it's not confusing.
It's not confused. Good.
Mm-mm.
Okay, now, no. Okay, number 4 is cubic root again of negative 27 x to the 8 power. Okay, let's do it step by step. Okay, I know que you can separate cubic root negative 27 and cubic root. Mentally, you can separate. No, not necessarily in the piece of paper. Mentally. And this is negative 3. You know very well. And here, no. Here, no. I try to find the multiple of 3 close to 8 down. Multiple of 3 is 3. 6, 9, no? 12. Okay. Well, let's down. So below, down. Is
And
6. Is
just
6. Go ahead, Jose.
just to make sure, Professor, the only reason we're able to use -3 is because it's cubed, correct?
Exactly.
Okay.
Exactly.
Okay.
Remember, si es square root, like that, suppose que I erase this, or put 4 even index, entonces no solution. No solution, no solution. Only we have solution when the index of the radical is odd
It's
number.
off. Okay.
Uh-huh. Uh-huh. Okay, now let's focus on the second part. In the second part, I discovered okay, the multiple of 3 close to 8 down is 6, right? And I separate, I split 8 and 8 to the 6 and 8 to the second, no? Okay, multiple of 3, this is the collection of multiple of 3 multiplied by 1, multiplied by 2, multiplied by 3, multiplied by 4, but no bigger. Because you put a bigger knife, maybe to say introduce artificially here negative exponent. Okay, I don't like negative exponent. Well, positive exponent is good. Now it's super easy. Compute the cubic root of this. Cubic root this is easy as 6 divided by 3 is 2. And stay alive cubic root x squared. Well. And professor, we cannot simplification this? No. The answer is no. Why not? How do you know? You stop. Because this power is smaller than the index. So you have cubic root x to the 40, and we can simplify. But you have cubic root x to the second, no. You have, for example, fifth root x to the 4. We cannot simplification because this number is smaller than this. But the minimum amount of factor that we need to simplification and the cubic root is 3. So you have 4, yes, we can simplification. Okay, so you have 6, yes, we can simplification. But this case, no simplification. Do you understand this idea or no? Yes or no?
Yes.
Yes, I understand it.
Excellent.
Yes,
So
Professor.
this answer will
Uh,
be -3 x
yes,
squared.
Negative 3. What the negative 3?
for the X.
Good. I forgot. I'm crazy. Thank you. You always help me. Okay, the answer, that part was this, but I forgot the negative 3. Okay, I copy. I copy the factor negative 3 here. And this is now my answer. Yes. Thank you. You always help me. Es Elsa, ¿no? Elsa. Who help me? Elsa.
And since so current too.
Okay. Okay. Number 5 is a division. So it's square root 12 x to the what power? Okay, don't see very well cubic power divided by 3x. Okay, guys. So now division. Sometimes we are doing separate in 2 parts, and sometimes no. Okay. This is a classical example in which you can separate this. This is equivalent, it's okay, but no es convenience. So you dedicate 1 second, only one, to see if it's possible simplification inside the radical. Yeah, of course, it's possible because 12 divided by 3 is 4, the x cubed minus 1x x squared. Okay, entonces you see if it's possible simplification. Si es not possible, you separate into. Now this is 2x because square root 2 and square root x to the second power is just x. And the story. Okay, let's practice one.
Professor, can you repeat that one more time? Why is it Oh, it's 4x squared because 12 can have 3x go in it
So you
4
say
times.
that part. So
Yeah,
basic.
like how do
Uh-huh.
we get to the 4x part?
Uh, oh, was 12 divided by 3 or 4
Mm.
and x cubic divided by x, subtracting the exponent. This is one invisible.
It's x squared. Okay.
Exactly.
Okay, got it.
Okay, now let's practice. Let's see the addition, subtraction, radical. And remember, we can condensing when you have the same radical. You have different radical, we cannot condense it. However, we need to verify if possible manipulations. Example number 6. Number 6, you have 2 radical 27 by radical 75. You say, wow, what the hell? This is impossible. Well, do simplification a little bit. You divide it by, you break it down this in prime factors. 27 is no even number. It's divisible by 3. And you detecting a couple of 3. Couple of 3 go outside like a 1. And these 3 multiplied by coefficients here get to 6. Actually, the simplification to radical 27 is 6 radical 3. Do you see this one?
Yes.
Liable.
Yes.
Uh-huh. 75 is divisible by 3. I guess so. How do you know it's divisible by 3, guys? The rule is clear. You have a big number, case complicated division. However, if you add in the digit 7 plus 5 gets 12, and this 12 is a number that belongs to the 3 multiplication table, this big number is divisible by 3. So I put in the calculator, 75 divided by 3 is 25. Divided by 3 is 25. And 25, 5 and 5. And this 5 and 5, again, is a couple of 5 can go outside like a 1, 5, and multiply by this 5 is 25. It's a coincidence. 25 what? 25 radical 3. This 3 is this 3. This 3 is this 3. And this 3 was this. Now, in this moment, you have, wow, fantastic. We have the same radical. And you combine the coefficients. 31 radical 3. Okay, it's 25 plus 6, no? Do you see?
Yeah, that was pretty easy.
Absolutely. Uh-huh. Number 7. Wow, bring me new situation. Because it's cubic root. Okay, but we try. It's the same idea, but be careful because in the cubic root you take 3 by 3 to say 5, 2, 16, 3, minus 18, the root of 2. Okay, let's doing. Now 16, prime factorization is divided by 2, 8, divided by 2 is 2. Okay, 4, and crazy. It's obvious, no? 16 is the multiplication 1, 2, 3, and 4, 2. But we are working with the cubic root. So these 3, 2 go outside like a 1, 2, and these 2 meet with the 5 is 10 because it's a factor. One typical mistake of the student is try to you put 2 plus 5 7. No, it's time. It's multiplication. It's a factor, and stay alive. 1, 2. Guess this. These 2 minus 18 cubic root of 2. Es obvio It's obvious that we cannot do anything in the second radical because 2 is a prime number. It's impossible simplification. And now ready to combine. 10 minus 18 is minus 8. Minus. Cool? Keep in mind the differences between the square root and cubic root. Cubic root, you take 3 by 3, or root 4 by 4, and so on. Let's do it number 8. Number 8 say 10 radical 40 minus 5 radical 50 plus 30 plus 30 no plus 3 radical 90. Simplification. This is 40, no? Two, no 90. 40. Okay, you don't know anything at the beginning. You break it down, break it down, break it down. 40 is the even number, 20. Okay, 2, 5. Now I see a couple of 2. They go outside like 1, 2. 22 times 10 is 20. 20 radical something, radical something, radical. The factor que stay inside is 2 and 5 together, que actually stay. It's totally unnecessary to write 2 times 5. No, hello. No, que 2 times 5 is 10. This is simplification of the first one. The second, 50 is even, is 25. 25, 5, and 5. The couple 5 we need to simplify. 5 outside, and 5 times 5 is 25. Radical 2. Radical 2. Radical 2. It is 2. And finally, 90. 90 divided by 2 is 45. 45, unfortunately, is divisible only by 3. 5, because 4 plus 5 is 9, no? Divided by 3 is 15, I guess so. 15, 15. 15 is 3 and 5. The only couple is this. 1, 3 outside. And this 3 times this 3 is 9. Radical something. What is the factor to stay alive? And in this case, this example was created to illustrate one thing. We can combine only the expression that contains the same radical. 20 and 9, 29. Radical 10. And this stay totally alone. Half radical 2. Cool. Okay, guys, one more and that's it. One more and that's it. And that's it. It's too much. Doing this was number 8. Number 9. Okay, number 9. Number 9. Number 9 is X. Wednesday we start new chapter. The last one. We almost finished, eh? And start in October something, 20 something, another subject. Suppose this. X radical 20x plus 4 radical 45 x cubed. Okay, factorization. 210 5. A couple of 2 both sides. We have 2x radical 5x. This 5 is this 5. That's the only possibility of simplification. 45 divided by 3 is 25, 5, 5. And this couple 5 go outside. I get 1, 5. Divide by 4 is 20. 20, 20. And stay inside the radical, this 3. Okay, this 3 is this. let's see what happened with the x cubed. X cubed in my mind, you separate x squared and x. And this is even. And x squared divided by 2, okay, we have invisible 2 here, is 1. And it stays 1x here. Okay, unfortunately, we have no common factor. No, these expressions are no like, unlike. Okay, no problema. Si it's online, entonces we cannot combine. You combine only the like term. Si it's online term, leave it like that. Look like similar,
Professor,
but uh-huh.
excuse me. In 45, you put 3 and 25. You break it down.
15 and 15. Sorry.
Okay.
Sorry. It's 15, right? And 15 is 3 and 5. 3 and 5, 3 and 5, 3 and 5. But the couple is not the couple 5, it's the couple 3, no? Nice. It's 3 and 5. Couple 3 represent 1, 3. Then 4 is 12. And we have 5 here. This 5 is this 5. Now it's lighter. It's light. And light, we can combine. It's 14. 12 plus 2, 14x. Now you get 5x. Thank you. This is wrong. The reason is that I want to finish, no? Because I am doing too fast. Okay. One more or no more? Do you understand very well this?
Yes, we understand it.
Entonces, I propose you finish here. And Wednesday, remember, turn into me. Test number 4 on paper online and by email, and submit your test number 4 online in Alex. Okay? Wednesday we start.
Professor,
Uh-huh.
how do we request a private meeting with you? Because there's no number on Canvas for you.
I explain every Friday. Every Friday. So you want to see in person. Every Friday, I am doing tutoring in the afternoon from 12 to 5 p.m. It's a one possibility. Another possibility, you are doing homework. I help a lot of students in this class. You are doing one homework and you are stuck in one problem, you send me the screenshot. Your problem, I solve for you in the one in the whiteboard like that. Yeah, I make a screenshot. Yeah, I send to you back, and a lot of students solve me this. Yes or no?
Yes.
Okay,
So,
it's a one possibility. As you want to see in person with me
mhm,
in campus, I am only Friday. Friday. Okay.
if I'm not able to do on campus because I'm not close to campus right now, how else would we get in contact with you via email or phone?
Uh-huh. 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 Now I have after this class, I have another class online. Well, I have another. So normally I working online, but in person tutoring Friday. Friday from 12 to 5 p.m. Okay, you don't set appointment. You are my students. Okay, you come here.
Okay.
As for me, yeah, I assist you in anything you want. You bring laptop,
Okay.
you open up Alex. Yeah, we sitting in one table and doing everything if
And
you
we
want.
do it together. Okay,
Yeah,
got it.
together.
And it's this same class link that we use 12 to 5?
What do you say? Repeat again.
We use this same class link 12 to 5 on Fridays,
No,
you
no,
mean?
no, no, no. No, I am here to assist any student that is coming here. I assisting the majority of the students I assisting is not my students. It's another class. Free.
Um,
Uh-huh.
Okay.
Another question. Guy,
Yeah.
I gotta go, guys. I need to prepare the next
Yes.
class.
Yes, Professor. This is fast. Okay. I checked the Alex thing that I have. I can give you like a straight answer to what happened to it. I think that the test that I did, because it says that I did test number 4, and I
Uh-huh.
ensure you that I haven't done it. So I think what happened was that I did test number 3 that now passed to be test number 4. So and then I just totally skipped the test number 3. So if you could give me like a chance to do it.
Yeah. Don't worry. You are Eddie, no?
Okay. Yes.
I gotta create extension.
Okay.
What
Thank
what time you need? What
you.
time you need?
Anytime. Today is even good.
Uh,
Like, oh,
next
you got.
what time? Extending 1 week.
Oh, yeah. 1 week is good.
Okay. Okay. Today is
Yeah,
second.
professor.
Uh-huh.
Test number 3, I did the paper test, but you didn't extend it for online. So if
For
you
you also.
open it up,
For you
yeah,
also.
if you open,
Guy, listen to me.
yes.
You talk to me now, but I don't remember you very well. I don't know your name clear. Email me. You email me. Yeah, I create extension. What's your name, Miss?
Grace Love, I
Okay.
did talk to you.
Ah, yeah,
I
yeah.
spoke to you twice,
Okay.
but the test number 3 never was extended. So I did the paper test, but I didn't get to do the online.
Oh, okay. Please, Grace, I understand now. However, you email me to remind me I need extension for the test number 3 and Alice. Okay.
Okay, no
Okay.
problem.
Okay.
Okay.
Okay, guys. Bye bye. See you.